Okay, so we had an opportunity to sine, so let's do some cosine. So in this case, b is equal to 4. That's greater than 1. So we are expecting a horizontal compression. Again, our new period, right, is our old period divided by b. So 2 pi over 4, giving us pi over 2. So we're really squishing it in. What used to happen over 4 quadrants, 0 to 2 pi, is now happening over 1 quadrant. All right, so we're basically taking this graph and really packing it in. As you'll see, it has a frequency of 4. So again, how do we do this? I think the easiest way, in my humble opinion, is to take what happens to some core points, right? Our core points on a cosine graph. At 0, we're 1. At pi over 2, we're 0. At pi, we're negative 1. At 3 pi over 2, we are 0. And at 2 pi, we're back at 1. So there's our normal cosine graph. So in red, right, what's going to be our new cosine of 4x graph? Well, again, since we're dividing the period by b, I got to divide all my x values by 4. Of course, if I divide by 4, that means I'm actually multiplying by its reciprocal 1/4. So I'm taking all these values and multiplying them by 1/4. The y values stay the same. We're not impacting them here. But 0 times 1/4 is 0. Pi over 2 times 1/4 is pi over 8. Pi times 1/4 is pi over 4. 3 pi over 2 over 4 is 3 pi over 8. And then 2 pi times 1/4, right, would be 2 pi over 4, which is pi over 2. And so scale-wise, we're still between 1 and negative 1. And then I'm going to cut up my x-axis, right? We're going to be at pi over 8, pi over 4, 3 pi over 8, and pi over 2. And so my first value is at 0, 1, pi over 8, 0, pi over 4, negative 1, 3 pi over 8, 0, and pi over 2, 1. So what does one cycle of this cosine of 4x look like? It looks like that. Okay? And so we have that. Again, comparing this to a normal sine graph, here's pi over 2. So somewhere way down over here would be pi, right? And then somewhere way down over here would be 3 pi over 2. And somewhere way over here would be 2 pi, right? I think I got pretty much those lengths. And so what a normal sine graph in blue was, it starts here at 1. Pi over 2 is at 0. Negative 1, right? Oops. I'm doing cosines. Yeah, cosine. Negative 3 pi over 2, 0, and 2 pi over 1. I had sine in my mind, sorry. So here's what the normal cosine graph looks like over its normal period, 0 to 2 pi. So you can see we took all that action and we really smashed it in. It's all basically happening in quad 1. And if you want to talk frequency, this would happen once, twice, 3 times, and 4 times. So we would say this new graph has a frequency of 4, all right? Because it would, over a normal period of over a full cycle, right? A normal rotation, it actually goes through its full motion 4 times. Okay, so there's one period, right? 2 period, 3 period, and then 4 period over the whole thing. So we've definitely packed it in like an accordion. All that stuff is packed in really nice. Alrighty. So what about cosine of 1/4 x? Well, again, same thing. B is equal to 1/4. This sits between 0 and 1. So I'm expecting a horizontal, stretch. My new period, right, is 2 pi over b. So this is 2 pi over 1/4, which is 2 pi times 4 over 1, so 8 pi. Alrighty, so this is really elongating. So what used to happen, right, normally from 0 to 2 pi is now happening from 0 to 8 pi. So we actually almost spin through 4 full circles, if you would, just to get one complete cosine graph for this guy here. Again, rather than thinking about all that, just manipulate the big point. So a cosine, its big boys, right, are 0 and 1, pi over 2 and 0, pi and -1, 3 pi over 2 and 0, and 2 pi and 1. So this is a normal cosine graph. So to get this graph, what I'm doing is taking all my x values and dividing them by 1/4. Of course, if I divide them by 1/4, the net effect is multiplying it by 4. So all of these are being multiplied by 4. So what's our new data points going to be? Well, these aren't changing. Okay, and 0 times 4 is 0. 4 times pi over 2, right, is 4 pi over 2, which is 2 pi. 4 times pi is 4 pi. 3 pi over 2, right, well, that would give us 12 pi over 2, which is 6 pi. And 2 pi times 4 is 8 pi. So you can see our big data point. So when it comes to graphing this, in terms of my scale, we can still get away with -1 and 1 along the y-axis. But on this axis, we're talking pi. Oops, we're talking 2 pi. And then 4 pi. And then 6 pi. And then 8 pi. And then graphing these points, at 0, we're at 1. At 2 pi, we're at 0. At 4 pi, we're at -1. At 6 pi, we're at 0. And 8 pi, we're +1. So here would be one cycle of cosine of 1/4 x. To compare that, right, what usually happens, right, is the cosine starts at 1, 0, 1, and here. So here's what cosine typically does, right, from one period, from 0 to 2 pi in blue. There's your cosine graph. Right, so what do we do with that graph? We elongated it, right? It's now taking from 0 to 8 pi to go through the same full range of motion. Start at a high point, bottom out midway, start back at a high point. That's basically your range of motion for cosine. So we basically took this graph and we stretched it. All right, vertical stretch. Okay, so next round, that takes us about 7 minutes. All my values have been really nice, right? 2s and 4s break up really nicely in terms of our quadrants. So what happens if we get something a little rough? We'll consider that in the next video.